Okay, good evening, and thank you everyone for joining us for exploring inverse relationships and equations. I'd like to introduce Dee Dee Stanfield. She is the Casio Teacher Advisory Council member who has put this presentation together. And before we get started, I just want to remind you, if you've been in our sessions before, this is not a surprise, but for audio quality, we have muted everybody. So if you have any questions, feel free to type them in the question panel that should be available on your screen, and I will respond to those, any of those questions. If any of them are of the sort that perhaps would apply to the whole group, I can certainly pass them on to Dee Dee. So we're glad to have Dee Dee with us, and without any further ado, I'll pass it over to you, Dee Dee.
All right, thank you. Good evening. Welcome to the webinar on exploring inverse relations and equations. My name is Dee Dee Stanfield, and I will be presenting tonight's session. I have been teaching mathematics for 21 years at Oxford High School in Alabama. Currently, I teach Algebra 2, Pre-Calculus, and AP Calculus. I'm nationally board certified and have earned my BS, MS, and EDS from Jacksonville State University. I began working formally for Casio about a year ago, but I have actually been using Casio's graphing calculators for around 22 years. Casio first produced the first graphing calculator in 1985. It was the FX7000G model. I received this calculator as a stocking stuffer from Santa Claus when I was 21 years old. Since that time, Casio has continued to improve and develop functionalities that other companies strive to match. I have been a speaker at many NCTM conventions and have conducted workshops for teachers of mathematics where graphing calculators such as a Prism were utilized as tools for strengthening students' understanding of mathematical concepts. Tonight we will examine ways to ease students into lessons involving inverses by using the Casio Prism graphing calculator. In teaching graphing concepts, I have learned from my experiences that if students are first allowed to explore graphs using graphing calculators, they gain an intuitive idea of how the characteristics of a graph change as a result of manipulating values within the equation. I kind of think of it like this. How could you draw a picture of an image if you did not have an idea of its appearance? If I asked you to draw a picture of a dog, immediately you would see images of many different dogs in your mind. Before you could draw one of these images, you'd probably want to know certain characteristics that define the particular dog you are attempting to draw, such as how fat, skinny, long, or short is a dog, or what kind of hair, curly or straight. To me, asking a student to graph an equation that they have no prior knowledge about is like asking someone who has never seen a dog to draw one. If they did not have an image bank for various types of graphs in their minds, then they are blindly performing point plotting without an intuitive notion of what to expect. The webinar will begin with the topic of inverse relations covered in algebra courses and then build toward more complex inverse equations. My objectives tonight are to discover the line of symmetry for all inverse graphs, analyze graphs in order to derive inverse equations algebraically and then verify by graphing, investigate graphs in order to state the domain and range of equations, and then determine and analyze equations in order to classify as functions and inverse functions. There will be a PDF available for the activities to follow once the webinar is archived at the Casio Education website. Please feel free to send any comments or questions to me personally at the email address that's listed. Well, to start with, what is an inverse relation after all? Well, in my 8th grade type classes, when I taught 8th grade algebra and algebra 1B, I try to start off with a very simple explanation that basically says that if you have an inverse relation, it will occur when the ordered pairs of a relation swap places. For example, if AB is a point in the relation, then the point BA would be a point in the inverse of the relation. Using the prism, we're going to graph the ordered pairs by plotting the points in the statistics icon found in the main menu. Below is the function or the relation that I am going to type in. So I'm going to change over to my emulator so that we can pull up the graph, and I will run through the ordered pairs again as we type them in. When you turn your calculator on, you can navigate around the main menu, all the different icons, by using the up and down arrow keys. And for today, or for tonight's lesson, we're going to toggle over to where it says statistics. When you enter the statistics icon, you do that by pressing execute. we have many different lists that we could fill in. We're going to let list 1 represent our x coordinates. So right here where the subject column is, or the subject row, we're going to put in this list 1 subject x for the x variables. We can do that by choosing alpha, using alpha. That's going to let me insert letters instead of numbers or symbols. The red letters correspond to the alpha letters. I hit execute to put the x in that list, and now I'm going to right arrow over and then go back up, and under list 2 where the subject, I want to choose to select alpha y. Okay, I'll give you a second to make sure you've got your subjects organized as x and y. You know, tonight we're just basically looking at a list of ordered pairs that we're using to represent x and y, but I try to start off sometimes making it more real by letting one of these topics be maybe Celsius and one be Fahrenheit, so that my list takes on greater meaning. But for tonight we're just using ordered pairs. Under list 1, my first x coordinate is going to be -3, so I use the negative key down here across to the left of the execute function. Then press execute to enter it into the list, and then likewise just keep going with -2, then -1. We're going to enter 0, 1, and 3. Now I purposely have listed my ordered pairs according to the x values increasing from least to greatest, and your -3 is to be paired with 0, so we already had a 0 there, so that's okay. I can enter it again and move on to the next pair. -2 is to be paired with 1. -1 is being paired with 0. 0 is paired with -2. 1 is paired with 0. And then lastly, 3 is being paired with -2. Now, in order to produce a graph of these ordered pairs, we're going to want to toggle or scroll over using F6 till we see some options on our soft menu that pertain to graphing. So I'm going to press F6, and I still do not see anything pertaining to graphing. So press F6 one more time, because that means there's still more options available. And there it is. Under F1, you have the above F1, you have the option to graph. Now press it just one time, and you see when you do that that you've got a graph 1, a graph 2, or a graph 3. Well, we're not really ready to graph yet, because since we're in the statistics menu, we could graph these ordered pairs as they relate to a histogram, a bar graph, a circle graph. There's many different types of graphs. Well, we're going to come down under Stat Graph 1 where it says Graph Type, and just look at the different options. You have your scatter plot, an XY line plot. You have pie graphs. If we toggle over to see more, we can hit F6 and see that you have your bar graph, I mentioned, the histograms. You could even do different polynomial functions. But tonight, to make our lines be piecewise graphs, we're going to choose the XY lines. Where it says X list, you should have a list 1 there. If you do not, you can click type on F1, and that lets you choose a number for your list. But like I said, we want to go with 1. We're wanting our values that were in our first list to be our X coordinates, and in list 2, those are your Y coordinates. So just make sure that for Stat Graph 1, we have list 1 and list 2 written down. Your frequency is 1. Where it under Mark Type, we can select an open box, an X, or a colored in box to represent the points. I've just chosen the solid box for this one. We will not be color linking this one. That would pertain to if you had like a pie graph and you wanted each section of the graph to represent something that you were analyzing. You could link the color to it. We're going to go ahead down to graph color though, and if you click on F1, you see that you could choose many different colors for your graph type. Well, we're going to choose for our first graph to be in blue. So I type on the number 2, and that brings up the color blue where it says graph color. Now hit execute, and then we're going to hit select, because before we graph, we want to make sure that we're only graphing what's down for Stat Graph 1. And Stat Graph 1 right now does say draw on, so but we don't want Stat Graph 2 on. So toggle down to it and press F2, which will turn it off. And now that it's off, press Draw. And there is our first relation that we have graphed. Well, we want to see the inverse of this relation and try to discover something. And as of right now, the only thing I've mentioned about an inverse is that simply you're going to swap your x and y coordinates. So for my list 3, I now want my y coordinates to be under list 3. So I'm going to type in the word, the letter alpha y, so that I have y. Whoops, sorry. I've got to give it a new name. So let's use alpha. Since this is an inverse, let's just abbreviate I, N, V, and then you can space, we'll say inverse, Y inverse. And then under this column, I want to copy what was in list 2 into list 3. So if I go up to the top right here and I move my mouse over till I'm in where it says list 3 and hit Option, options bring up these different options here. I want to copy a list, so I'm going to hit F1 and then F1 one more time so that I can tell it which list to copy. I want to copy list 2 into list 3. So press the 2 button and execute, and you can see that copies over your list 2. We basically want to do the same thing under list 4. Let's name this column. I will name it X and then inverse so that it too has a different name from what we started with. So X inverse. Again, we want to copy, so I'm going to go toggle up to list 4, press Option, F1, F1 again, and this time remember I'm wanting to bring list 1 over, so I press the 1 button and execute. Alright, wait just a second to make sure you've got your list. You can just verify that what's in list 1 is now in list 4, what was in list 2 copied over to list 3. Press Exit twice so you see Graph appear again as an option above F1. Press F1. We want to set this one up. We're wanting to create a graph now for list 3 and list 4. So press F6, and when you do, we don't want to redefine StatGraph 1. We want to define StatGraph 2. So press F2 to change this to StatGraph 2. Now come down, make sure that for graph type, you once again have chosen an XY line. And this is very important this time. For your X coordinates for this graph, you want to use the data that was in list 2. So if you do not have list 2, to the right of X list, press list and then press 2, and that will allow you to change that to list 2. Your Y list needs to correspond to the X values that were in list 1. So again, you can press F1 and then 1 to make sure this is list 1. I still have a frequency of 1, and I have changed the marking type for this graph to X's. That way, if I've got some points lying on top of each other, I can kind of distinctly tell that they're not, that there's 2 points basically at the same point. Color link is still off, and let's choose to make this color different. We do not want to do another blue graph because it would look like the first graph. So I chose 3, so press 3 for red, and now select. Now, before we just saw StatGraph 1, now we want to see StatGraph 1 and 2 simultaneously. So I come down to StatGraph 2, press F1 to turn it on, press F6 to draw it, and when you do that, you see that you've got both the original relation and the inverse function. Now, the difference here is that when you drew just the the original relation, the graph paper was very square. It looked very exactly the scale to the left and right made the graph appear very squared up. And now, because you had to fit everything that's far left and right had to appear on the graph, as y coordinates here. So instead of going out to 3, you had to be able to go up to 3, and left to -3, now it's down to -3. So the calculator automatically rescales the graph paper so that it fits the problem. I'm going to go back to the power slide for just a minute and show you a neat feature that I'm using here tonight is the emulator software for the Prism. And what's really great about it is that when you have your emulator software, you can cut and paste anything from your graph icons or your screen to a Word document or to a PowerPoint. So what I did was I cut and pasted the document or the picture that we just graphed onto this presentation, and I've taken the corners of it, and you can see you can stretch it when you've got it in a Word document so that you can create the grid to look more square-like again. If I take this graph and stretch it so that it's more square-like, it's real easy to look at the graph and see that it is symmetric about a certain line. And here's where we're going to really try to, get the students to look at this and sketch their own line. Where do you think I could fold this graph and it would be like a mirror image of each side? And hopefully if they plot a few points or they sketch a line off of, after doing about 4 or 5 of these different graphs, they realize that every graph, when you swap the x and y ordered pairs, is reflected over the line y equals x. So that begins your idea of a line of symmetry for graphs, or the line y equals x is your line of reflection. I'm going to go back now to my calculator. And from here, if you look at the, when you get your archived lesson, the PDF that's going to be attached, you'll have 4 more problems so that you can divide your students up in groups, and they're written where when they graph them, they're going to get different graphs such as this. And what I usually do in a classroom is have the students explore these graphs using the graphing calculator so they kind of get an idea of what the pictures will be, and they tend to get more motivated and work together when they're using their calculators. And then I'll give them easel-sized graph paper, and they go back and do these kind of graphs on a larger piece of paper in blue and red, and we hang them across the room. And if someone has still not really picked up on their own that there's a line y equals x that's dividing each of these graphs symmetrically, then we come back and we really look at all the pictures together around the room, and that kind of helps them build a better understanding of that. Now that takes care of the inverse relation activity. Now we're going to look at discovering inverse functions graphically. Recall that a function is a set of ordered pairs of numbers where no 2 ordered pairs have the same first number. Therefore, for the inverse of a function, an inverse requires the x and y coordinates to swap places within the ordered pair. To be a function, then both the first and second number have to be unique. Such functions are called one-to-one functions, and will pass not only the vertical line test but the horizontal line test as well. So let's go back now to my calculator, and we're going to graph an equation. We're going to, this time, we're going to go back to our menu, main menu, and move to the graph icon. We're going to explore this from a different angle. When you go to the graph icon, you always want to make sure that you start out with a clear slate here. So if you've got anything left in your calculator from before, make sure you delete it by pressing F2 and then F1 to delete anything that's stored previously. And for right now, we're going to type in a very simple Algebra 1 type equation. We're going to type in 2x and use this key. It's underneath the alpha key. This is your variable key. We're going to type in 2x plus 4 and store it. And we are going to want to draw this. And before we graph it, let's go ahead and adjust our view window to a nice view window. The one neat thing about the Prism and the Casio calculators, when you hit Shift and then F3 for view window, you're going to have some preset view windows that you can choose from. There's one that's really good for trigonometric graphs. There's a standard view window, which basically sets your graph paper from -10 to 10 for both x and y. And there's an initialized screen, which really creates a square grid so that your paper, when you graph on this calculator, it looks like graph paper. So press the execute key twice once you've pressed F1 for the initial view window values. When you press it twice, you're going to create that graph. Now, this is a nice graph, and I can see that it crosses -2 precisely at 0, but I really can't see where it's crossing the y-axis. You can press the up key, and that's going to let you, just like sliding your graph paper, so that you can see more of what's above. If I want to see what's above, I press up. If I wanted to see more to the right, I could press right. You can just readjust your graph paper without having to regraph the problem. Now, I want to see what the inverse of this graph looks like. Now, I know it's when all the points along this line swap places. In other words, -2, 0 should have a point at 0, -2. -1, 2 should change and have a value at 2, -1. And 0, 4 should have a point crossing at 4, 0. Students may not realize that yet. They may not know what that picture looks like. So we want to help them develop an intuitive idea by showing them that they can press Shift and then F4 for sketch. And when you press Shift F4, you've got all these different options here. But today, we're actually wanting to graph the inverse. So press F4 for inverse. And you can see the inverse. I'm not really getting a good picture of it because it's down below. In order to see this a little better, I could go back and maybe I decided, well, maybe I do need to see more of the graph from below. We could toggle down a couple of notches and then go back and hit Shift, Sketch, and sketch the inverse again. Now I can see it a little more clearly. Let's verify the points. -2, 0 was this point on the relation. So on the inverse is 0, -2 on my graph, and you can see that is. At -1, we had a point at 2. So over here, I should be able to go to 2, -1, and see a point. I can see that at -3, I had a value at -2. So over here, I should be able to go to -2 and see a value at -3. So we could pick random points on the blue line, swap or switch the X and Y positions, and find those same points on our graph. Now, did 2x plus 4 represent a function? Well, the way we've been taught, probably initially, we teach students that a graph is a function if it passes the vertical line test. So this graph most definitely passes a vertical line test because it's a linear function with a defined slope, so it is okay. Would the inverse represent a function? Well, by looking at this graph, I can definitely see that this inverse does represent a function because it too would pass the vertical line test. Stating the domain and the range of linear functions gets to be kind of monotonous, and I think sometimes teachers tend not to spend enough time teaching the domain and range of these linear functions because, you know, really we're saying for every x there is a y, and for every y there is an x. So the domain here would be unrestricted. Any value could be an element of the domain, and any value could be an element of the range. But when we start looking at graphs that have curves, or maybe they don't forever increase or they don't forever decrease, if they have concavity, different things like that, when you move to higher level functions, you need to really already understand what a domain and a range is with respect to a graph. So let's go back and think now. We started off with the definition today of what one-to-one would mean. One-to-one means that this line would pass both the vertical and a horizontal line test. And I believe we can see that this blue line does pass a vertical and horizontal line test, so we can say that it's one-to-one. What if we wanted to find the equation of this pink line? Now, algebraically, you were taught y equals 2x plus 4 was our original blue line, that if we take the same idea that we used to find a relation, which was to swap the x and y ordered pairs, we can do that to our equation. If we swap our x and y ordered pairs, we're going to solve for our new y, and you will get the equation 1/2 x minus 2. We're going to enter that as y2 and verify that that is the equation that represents our inverse, because we already know what the inverse of this line looks like. So let's see if this new equation we've derived matches the inverse. One of the neat features about the Prism is the text-friendly typeset. I can type in 1 as the numerator of my fraction, 2 as the denominator, right-click over, enter an x variable, and then enter minus 2. And this equation is going to graph in red. That's another, the first graph was in blue, the second graph will be in red. Every graph that you enter will be a different color, so it's easy to compare them. Once you've entered that equation, let's press F6 twice, or you can press the execute key either way, and you're going to see there's the inverse. Now recall, on the blue graph, we'd already said that it passed through -2, 0. So this graph is also passing through 0, -2. The graph passed through -3, -2. The red graph is crossing through -2, -3. I had a point at -1, 2 on the relation. So on this graph at 2, -1, we still have a point. If 3 of these points that we already found previously were on the inverse graph, and this graph that we derived produced a line passing through those same 3 points, then we're pretty sure we have algebraically found the correct inverse equation. Now this was an example of a very easy linear example. We're going to take it up a notch and now look at some equations that are a little more complicated. Before we do that, we need to clean up our screen. So I'm going to go through and delete the previous functions by pressing F2 and F1 over each one of them. My next equation I'm going to graph is going to start off with 2 minus, we're going to hit shift and square root. I chose some functions so you could really see just how neat the text, the text font looks when we're on the graph screen, because you're actually seeing what the student would see on a textbook or as how they would write it down on their paper. So we're going to type in 2 minus the square root of x plus 1. And probably the view window we were using will be good for this. So we will store it by pressing execute. You can either press F6 or execute again to create this graph. And you can see this is basically a square root graph that was turned upside down. You could go back and review with the students, why is this square root graph shifted left 1 and up 2 and reflected vertically? Because those are concepts that they can really have gained already. They should have gained already before they start doing the inverse graphs. Now, once again, I want to see what the inverse is going to look like. So I'm going to hit Shift and Sketch and F4 for inverse. And hopefully, if you do enough of these, your students are going to start seeing a pattern where the blue graph was going kind of down and right. As I read it from left to right, it was going down and right. The Y graph, if you read it from right to left, because we are reversing everything, is going left and up. And that's kind of a relationship that they're always going to see. And again, if they were to look at the line, the reflection line, they could see that if I sketched a line connecting from -1, 1 to 0, 0, 1, 1, 2, 2, that there would be the line y equals x, definitely cutting this in half symmetrically again. We could take points along this graph and verify that the inverse of those points are on this graph as well. So this function has this relation, this inverse function. And I did call it a function. And why is it a function? It's a function because, again, it passes the vertical line test. You can see the pink graph is passing the horizontal line test. So we know that this graph was a one-to-one function. If the blue graph passes the vertical line test and its inverse passes the vertical line test, then that really means the blue graph passed both the vertical and horizontal line test. And in looking at this, we could talk about the domain again. Let's really focus on the domain of the function. The domain is what can x be? Well, you look and see their blue graph went as far left as -1, but then it continued to the right forever. So we would say that the domain of the original function was from -1 inclusively to positive infinity. The range of the blue graph, it went as high as 2, and it's going as low as negative infinity. So the range values for y, we would say range from +2, or we probably would start with a negative, say from negative infinity all the way to 2. Now how has that changed? How is that different when we look at the pink graph? Well, the inverses graph, think about this, it's going to positive infinity for y, and it's going over to 2 for the x. So my domain of the inverse function is from positive infinity, because it's going left forever, all the way to 2. The range of the pink graph is going up to infinity, and it's going down to -1. So my range for the graph, the inverse graph, would be from -1 to positive infinity. Would you consider the blue graph to be a one-to-one function? I believe I answered that previously by saying this graph passes both the vertical and horizontal line test. And if we sat down and with a pencil and paper and we swapped our x and our y and we went back and we really solved and created the equation for this, we would see that the equation of the pink line would look something like this. You would end up with 2, let's see if I wrote this down correctly. If you solve for it, you would have 2 minus the square root. Let's see, I believe I mistyped that, sorry, second, hold on a minute. We've got parentheses negative x plus 2 squared minus 1. If you swapped your x and your y in your original equation and solve for the new y, whoa, look at there. You know what I forgot to do? I still have a bad habit. I've got to right-click that and then subtract 1. If you don't, it's subtracting it from the exponent instead of the function. So these are mistakes you have to really help students learn to watch too. Now when I graph this, we're going to have a problem. You see that when I graph the inverse by solving it, I've got a complete parabola, and I only wanted to have one leg of this. So we're going to look at how to go back and restrict this domain. I need to restrict this domain. In other words, I just want to create a piecewise function. So I can hit comma, and I'm going to use my bracket. I only wanted to see this graph, if you think about it now. If you recall that the graph was, we only wanted to see it to the right of 2, so I'm going to say 2, comma, leave it blank. That means infinity when you have a blank there. Close your bracket and then graph it. And now when I graph this, I only see that restricted portion of the graph that I needed to see. So we only wanted to reflect it, so we had to restrict our domain on our inverse so that we only saw the portion of the graph that we wanted to see. All right, let's try another one. Let's see what else we can play around with here. I need to delete this.
Quick check, Dee Dee.
Okay.
All
right.
I was trying to catch you before you deleted that.
All right.
Well, just you had drawn the right-hand side, and I was wondering.
Oh, I drew the wrong side.
I think you did. I was wondering if I may have missed something. So I was just checking.
Let's go back and graph it again. Negative x plus 2 squared was the function minus 1. Whoops, I went back in front of it. Let's try that. I'm glad you stopped me. I needed a break. All right, here's the original graph. So this one had a graph, let's see, we were graphing from -1 to positive infinity for x. So for this, and the y was from 2 to negative infinity. So this one should be from, let's see, we really want to see the left side of the graph. You're right. So we need to come back and, let me get back to there. We want to go, we can just leave the first part of the thing blank if we want it to be to negative infinity, the first value, and then click to, press 2, and then close the bracket. And let's see if that does it. There, that looks better. Thank you, Nathan. I had graphed the wrong side, but that's one of the neat things I love about this one is that you can restrict your domain on your graph so that you only graph what you need to see, because you can only see that part of the graph if it's a relation that matched up. All right, let's try one more. I'm going to delete this one and delete the other one, and we're going to do a cubic function this time. So my cubic function that we're going to try is x minus 2. I'm sorry, I said x minus 2. I meant x minus 1 to the third power. And we're going to add 2 to it. So we've got a transformation of a graph shifted right 1 and up 2. And hopefully you can get them to tell you that before you actually let them graph if they've experienced transformation rules already. So here is my graph, and we want to see the inverse of this graph. So let's go Shift, Sketch, and then F4 again for the inverse, and you see this graph. Now, as we start to analyze it again, and we want to look and see if the y equals x is still serving as the reflection line. I believe you can see that it is. And we want to also talk about whether or not these were functions, or each of the graphs individually functions if you look at them. And you can tell the blue line passes the vertical line test, and the pink line also passes the vertical line test. So this does represent a pair of inverse functions. When we look at the domain of the blue graph, you see the domain, any x could be plugged in and it would have a y value, and any x, and even on the pink graph, any x coordinate would pertain to some y graph. For every x there is a y, and for every y there is an x. So there's no restriction again on our domains here. If we look at points along this graph, we can plot them and see that their inverse relation is here. And if you come back and graph the, if you come back to the algebra way of finding the inverse, and you solve for x, or you solve for y after you swap x and y, let's see, you're going to have x minus 2 cube rooted plus 1. So let's graph that and see if it appears to be the same graph as the pink graph. So we're going to try that. In order to input this, I usually put the constant first, 1 plus, and I want a cube root. Now there is a cube root actually built into the calculator above the parenthesis key, but also above the caret key or the power key there's an x root, so you can use this one to put in any value. Since cube root is one that's actually defined on the function on the keys, I'll just go and use the cube root and type in x minus 2, and I'm going to store that, and let's graph it now and see if this graph appears to lie on top of where we had the other graph. And if you had the ordered pairs written down from the first relation and its inverse, you can verify that this graph does pass through those same points. Another way that I have not gone over in this presentation due to the sake of time is that you can take a screenshot with your emulator or with your handheld. You can capture your screen and you can save it as a picture and open it up under a different mode called picture plot, and you could take the inverse that you sketched from the sketch menu, and you can, well, this is a roller coaster, but if you imported it into your picture plot, you could actually plot points along the graph and use your regression features to actually generate some equations. If you've not played with picture plot or the regression features of that is another neat webinar, or you can find all kinds of activities and lessons at the Casio website that demonstrate that. It's a very neat thing. Okay, so we've got this one. We now know that we've seen this inverse. One thing I want to point out here too, and hopefully you're starting to see a relationship of what kinds of graphs are going to be one-to-one. So far, everything we've done has been one-to-one. Well, this next graph is not going to be one-to-one, and let's see if you can tell me why. I'm going to delete this graph and enter the last one for the night. The last one we're going to do starts off with x plus 3 squared minus 4. Most of us realize that's a parabola shifted left 3 and down 4, so let's see what the graph looks like. Oh, I can't see it very well, so I'm going to remember that I can shift my graph paper left by pressing left, and I want to shift it downward so I can see the vertex of this parabola. We could have went in and just adjusted the view window to fit the problem, but sometimes it's just easier to move it to where you want to position it. Now I'm going to graph the inverse, so shift, sketch, F4 for inverse, and I can see that this inverse is a parabola turned sideways. I'm going to shift it down just one notch and regraph that inverse one more time. We still have a relation that's been inverted. We can still draw the line y equals x, and we see that this graph does have an inverse. Every graph has an inverse. The problem is not every graph has an inverse function. A parabola itself, a vertical parabola, is an inverse, is a function. But when you turn it sideways, when you turn it so that it's no longer a vertical parabola but a horizontal parabola, you see that the pink graph is going to fail the vertical line test. And your blue graph, you can say, passes the vertical but not the horizontal line test. So if you only had the blue graph, I'm going to exit out and regraph that. Well, didn't, but if you just had the blue graph visible, you would see that it had to pass both the vertical and horizontal line test for it to have an inverse function. It does indeed have an inverse, but not an inverse function. And so to solve for this graph, we've got to add the 4, swap the x and y, and then add the 4, take the square root, and when you take that square root, you're going to encounter a problem that's going to make it a little more difficult. If we just look at our calculator screen right here and we want to enter the plus or minus the square root of x plus 4 minus 3, there's not a way to enter plus or minus at the same time. So we've got to enter two separate functions to represent, or two different equations to represent the inverse of this graph. I'm going to hit shift square root and type in x plus 4, toggle over to minus 3, and that represents the upward arm, the arm that's kind of rising as it goes to the right. And now I need to put negative and then square root of x plus 4 minus 3 to represent the other half of that parabola. Now when we graph it, we should get an equation that matches up to what we said the inverse was. So this kind of gives you practice. If you see the inverse based on what the calculator is, you're having to figure out what equation would mimic that graph, or you can type it in to verify it. One of the things that I hope that students will draw from this lesson is, after doing a lot of experimentation and looking at different graphs, that one of the big things that they need to draw from this is that a function will be one-to-one if the original function is either entirely increasing or entirely decreasing on its entire domain. You can see this graph as an example of a graph that was decreasing, and then it turned and became an increasing graph. So it basically, when it had this point of, when it changed direction, that causes it not to have an inverse function when you take the inverse of it. Our last screen tonight is going to be one that basically Nathan's going to explain about the online courses that are available now through Casio Education. I appreciate you bearing with me tonight. This was my first webinar, and hopefully I'll iron out the bugs in the future. Thank you.
Thank you very much, Dee Dee. That was a pleasure. So just want to wrap it up by letting everybody know, some of you may have already heard, we have this online training course for the Prism that Dee Dee was using this evening. It's a free course, and it's just designed to make sure that you know how to use it, or to answer any questions you might have about it generated from the session today. It's a free course, and in addition to that, right now, and of course this is what is this, the 29th of May 2012, just to make sure, because we're going to be archiving this. I don't want to make any promises outside the immediate future, but certainly for the time being, those who finish this course are receiving either the emulator software or their calculator just for their time spent. It's perhaps 5 or 6 hours of your time, so we want to encourage you to take a look at that. Thank you again, Dee Dee. I enjoyed it, and thank you everyone who joined us this evening.